passage on the screen here. The heavens declare the glory of God. The skies proclaim the work of his hands. Day after day they pour forth speech. Night after night they display knowledge. There's so much true about that passage that it's hard to cover it all. We're going to be looking out in the cosmos here for this last section of our class starting today. And it's amazing what you see. It's amazing what you see in the world when you look around us, as we spent some time looking at things just on normal resolution, all the creatures God made. We zoomed in here for a few weeks, looked at some of the microbiology, just totally amazing. We looked at some of the things, the machines that are made or that are in the body that could not happen by accident. And DNA, we talked about that last week and how complicated that is. And there's just no way to answer the question in a natural way. How did the first DNA molecule and the first proteins ever come around? It had to be made, had to be designed, and then made by a creator. And our creator, of course, and the creator is Jehovah God. So we spent that time. So the conclusion we have is that we need to praise the Lord, because you look out in the universe or you look down inside our bodies and you see that we're fearfully and wonderfully made. Marvelous are your works, and that my soul knows very well. That's our understanding, at least most of us here, that is the truth, that God made us. It could not have happened any other way. But we're looking at the evidence that would show that to someone who maybe doesn't have that confidence through the scriptures, and trying to persuade those who might still think, yeah, everything happened by chance, and the whole universe, in fact, came into existence from one big, huge explosion, and everything came out the way it is today. So we're going to look at that closely today as we look at the design in the cosmos, or the universe. And there's so much to cover here, obviously. We're only going to be covering a little bit. I mean, this is probably one of the hugest areas of science that really show how clearly it is that there's evidence for God creating all of us. Not just our bodies, not just this planet, but the entire universe shows so many signatures of design, and that it must have been created. There's so many conditions just right for life. When you look at our planet, here we covered the molecular, the discoveries in molecular biology reveal that the cell is far too complex to come about by natural accident or causes. We've looked at that. Just the same, the odds that all the conditions necessary for complex life, that's you and me, complex life and animals, should come together by chance on our planet is just as impossible. So you look at, we spent a few weeks looking at those molecular machines and how amazing they are. Impossible to happen by accident. Same thing is true when you look out into the vastness of space and look around actually at our own world, which we're going to start with that. Just look at the Earth and see just how amazing it is, and it is not something that came about accidentally. Isaiah 45, verse 18. For thus saith the Lord, who created the heavens. He is the God who formed the earth and made it. He established it and did not create it a waste place, but formed it to be inhabited. I am the Lord, and there is no other. This is an insightful passage of Scripture. You look out in the cosmos and you see a lot of bodies and things that exist, planets and stars, and most all of them are waste places. You can't live there. When you go to Mars, you better take your own oxygen and radiation protection. You go to Venus, poisonous gases, Mercury way too hot, just on and on you could go. They're waste places, but God made this place to be inhabited. That's what the scripture says, and that's what the evidence shows, is our God is the creator. Most people have heard of this guy, Isaac Newton. In his Principia, book 3, he said, atheism is so senseless. When I look at the solar system, I see the Earth at the right distance from the sun to receive the proper amounts of heat and light. This did not happen by chance. And so this guy figured, he didn't have a lot of technical equipment back then, but he could figure out, it's just common sense. Look, it's too just right for being able to live here. And so many places in the universe just don't, it wouldn't happen. It wouldn't be something that could support life. He continues and says, this most beautiful system of the sun and planets and comets could only proceed from the counsel and dominion of an intelligent and powerful being. Amen. That is what common sense would tell each of us. He believed that, like many scientists of his day, a number of them, they believed that God had to make it all. It wasn't until later on it became more popular for scientists to believe in evolution and that all things came together by chance. Some of these brilliant men and women understood that it was not possible for things to come together by accident. Let's take a look at our world. You know, maybe that's not the way you look at our world, but we're going to look at it this way. The world we live on, and some of these images here, by the way, I've got to give credit to Privileged Planet. It's a video series, and I forget, I think it's Discovery Institute, put together a wonderful video that I recommend you watch and buy, for that matter, called Privileged Planet. That we live in a place of privilege and not something that could come about by accident. And so you look at this planet, and it's got so many different parts about it, so many different things about it, so many different situations where these things had to be, and not just by themselves, but all together, they fit together like this puzzle and make up this world that we live on. And it's just a wonderful thing to see when you start looking. We're going to look at a few of these qualities, these characteristics, and add it up and just see how amazing it is, the evidence that God made our world and everything that makes our world possible, which of course is the rest of a solar system and the universe. Let's start off with something we're pretty familiar with. Looks like one of the waves I surfed on this last week. Actually, we were only boogie boarding, and it was too cold to do that for more than about 10 minutes. So anyway, it does look like some of the waves, a little bit larger than some of the waves we saw down at Seaside. But liquid water. Liquid water is something that's very rare in the universe. The chemical properties of water are exquisitely suited for the carbon-based life. You got to have water if you're going to have life. Just has to be. Everything depends on it. Sustains it. I mean, you look at our water, our body's 75% water, I think it is, you know. So, I mean, it's just totally essential. And we have it in abundance. Water has the ability to dissolve and transport the chemical nutrients vital to all living organisms. It's a must. It's not an elective. You gotta have it. It also is unmatched in its capacity to absorb heat from the sun, which is critical in regulating the Earth's surface temperature. You look at worlds that don't have water, extreme temperatures back and forth, even if they're in a particular favorable orbit. They have these extreme temperatures that vary during the day and during their seasons. Water regulates all this, helps us to regulate these temperatures. And water existence hinges directly on a planet's distance from its home star. This is something that is so critical. Here's our cosmos here. Here's our sun, the planets coming out, and there's a little blue area right where we live called the circumstellar habitable zone, or you can call it what a lot of people do, the Goldilocks zone. Not too hot, not too cold, but just right for all the things that are needed for our lives to exist. If the Earth was just 5% closer to the sun, all water would boil off, like on Venus, and it would reach about 900 degrees Fahrenheit. That's pretty hot. We thought it was pretty hot when it got to 90, 95, almost 100 this summer. Yeah, that's nothing. Hot for you and me, maybe, because we're Washingtonians, but nothing. So yeah, just a little bit closer, and then we would have that kind of condition. If we were just 20% farther, carbon dioxide clouds would form in the upper atmosphere, causing a cycle of ice and cold like the things we see on Mars. Mars is too far from the sun to really be, to produce a natural, or to sustain a natural atmosphere and living conditions. Okay, so we've got water, we've got the right distance from the sun. We're a terrestrial planet, a rock planet. We live on a paper-thin crust, which varies in thickness about 5 to 25 miles. and below us is a semi-solid mantle, and then the outer core, which is partly liquid, and then the inner core, which is liquid. But this crust on the outside, this is up again, it's unusual in a lot of planets. And it's absolutely necessary for us to have the kind of climate and the kind of living conditions that we have. Again, we're adding up these things, one condition after another condition after another condition, until you basically have to say, that was arranged. That didn't happen by chance. So this crust consists of more than a dozen tectonic plates. You probably heard about those. We think it's just a solid globe. It's not solid. The crust isn't solid. It's actually broken, broken intentionally, and they're in constant motion. If there were any thicker, then plate tectonic recycling could not take place. Just the way the Earth, it's almost like a living organism, the Earth. This dynamic geology regulates the planet's internal temperature. And so the way that these things work, and they cool off the mantle when necessary and let it heat up when necessary. This kind of technology, this dynamic geology rather, recycles carbon, which that has to be done, mixes chemical elements essential to living organisms. All these things it does because it is made the way it is. We have a magnetic field. Okay, deep within the Earth's interior, the movement of liquid iron generates a protective magnetic field essential to complex life. And at our home, magnets are for playing with, but for the Earth, it's survival. So you've got this thing that you can't see all around you, these magnetic lines of flux that come out and that protect the Earth from the solar rays that come in. Now, it's kind of funny because the sun is essential for life, but it's also so powerful that without a certain kind of protection, we're going to die. The magnetic force resists and blocks this radiation along with our atmosphere, which we'll talk about in a minute. So this is a setup, guys. It's a setup. This planet was made intentionally to be inhabited because we have the sun, which we need, but we have protection against its harmful effects. And so that's amazing. Sam.
This is something that, of course, scientists talk about of our planet having, right? And they're really impressed with it, right? And they like to study it and all that sort of stuff, but they don't really explain how amazing it is. I mean, you look at that bacterial flagellum, right, which is a motor, right? The fact that we have an iron core in a what?
Liquid iron.
Liquid iron core.
Has to be liquid.
They won't tell you about these details really, floating in the center, and that it's rotating in the opposite direction that our planet rotates, which it needs to be doing that to generate this field. And so you have an electric machinery here, right? The planet really is
that makes
something
that
you can simulate in class.
Force fields were.
I mean, when I was, I went to science class and we kind of did the same thing with, metal and copper wire and stuff like that, and stuff. You can make interesting things. God has made our planet to function under a similar situation. They don't understand, how does the core spin the opposite direction? Who did that? How did that come about? Because in their basic science of formation of planets, that shouldn't be possible. Everything should be spinning in the same direction, and gravity brings it together. And then that makes your rotation of the planet kind of thing. How does the core spin the opposite direction? How do you get that going? Yeah. So they'll talk about this amazing force field that we have because it's amazing to them. They won't give you much detail about how amazing it is and how much of a functioning system it is. That'd be hard to do by chance. Anyway.
Yeah, explain it by chance.
And just to make a comment that you're probably going to make.
Go ahead.
I mean, there's the Goldilocks zone, right, which Mars is not in, and there's huge talk about, finding life on Mars and making it habitable. Elon Musk is ready to terraform it for us if we need an atmosphere.
That's right.
All that sort of stuff. But does it have a core like this? Does it have a force field like this? Yeah. Will it work? That's the question. It's just one of the variables. There's a lot of planets out there, but do they have this core and this magnetic field? So anyway.
They have a small one. but not effective enough to do what this one, how this one works. Yeah, again, you bring your own radiation shield when you go to Mars. You better, anyway. I mean, you live there for a little while without it, but not for very long. So yeah, just an amazing technological part of what our Earth does. And it is a force field, protects us from the harmful rays that the sun puts out. If our planet were any smaller even, the solar winds would strip away our atmosphere. So just the right size so that the solar winds, and that's what's being represented here by the gamma and X-ray radiation coming from the sun, is deflected. And we're not, I mean, we still get a little bit of it. Obviously, you go outside, you're going to get, and you stay out there without sunscreen, you're going to get sunburn. Ultraviolet light doesn't block all the ultraviolet light. But the harmful radiation like X-rays, gamma rays, neutron rays, other things it does block. Okay, moving on. Our planet has an oxygen-nitrogen atmosphere. Our atmosphere is composed of a mixture of 78% nitrogen, 21% oxygen, and 1% carbon dioxide. This composition assures a temperate climate, it's a balanced climate, protection from the sun's radiation. It's the secondary system that protects from radiation, the correct combinations of gases for liquid, water, and complex life. We take it for granted. I mean, we get up every morning, walk outside, and breathe, right? Which any kind of complex life would need that. You can't do that on Mars. You can't do it on any other planet in this solar system. They've discovered 1 or 2 planets in the galaxy that might have some oxygen. They're not sure. They're too far away to tell for sure. So rare. The same atmosphere that makes complex life possible and that allows us to breathe is also transparent, therefore making scientific discovery possible. So we can look out. Not only can we breathe this atmosphere, but unlike so many atmospheres that exist around planets, we can see through it. Because we can see through it, we can see how amazing the universe is. If you lived on Venus, if it was possible to live there, you wouldn't know anything about the solar system. It's all just a thick blanket after blanket after blanket of mostly methane gases that are on Mars. Easy, nice to burn, hard to breathe. Okay, Saturn, the same thing, beautiful planet that we can see from Earth, but you couldn't see Earth from there. Jupiter, the same thing, a little heavy, you'd be a little heavier on Jupiter if you lived there, but you wouldn't be able to see anything else. Uranus, Neptune, all have atmospheres that you can't see out of. We have one where you can look out and see. And we'll talk more about that in just a bit when we combine that with some other facts about this world that God has made. We have a moon, a large moon. It's unusual for planets to have a planet our size to have such a large moon. They're usually much smaller. And so what happens is our moon is able to stabilize the angle of the Earth's axis at this 23.5 degrees, which is ideal for seasons. We have beautiful seasons, summer and winter, and we don't have parts of our planet that are frozen. Well, we do have parts of our planet that are frozen all the time to the poles, but most of the planet enjoys this variation of seasons. And having this larger moon assures a relatively temperate seasonal changes. Won't even talk about how it affects the tides and the way it does, which allows marine life to exist in the way that it does. Okay, just kind of throwing a few things, just kind of numbering these or adding these up. Type of star that we orbit, which is known as a spectral type G2 dwarf main sequence star. So it's a particular kind of star. It is, if the sun were less massive, like 90% of the stars in the galaxy, so it's unusual to have a sun this size, the habitable zone would be smaller, so it'd move in, and if we had to be in that habitable zone, then the increased gravity would lock our rotation and cause one side of the planet always to face the sun, and that wouldn't be good for the people on the sun side or for the people on the other side. Okay, but because the sun is the size it is and we're where we are, we don't have those kinds of problems. Okay, moving out further, we're looking there at the sun, and the Earth, and the solar system. We're in the galactic habitable zone. So not only we are in the right place in our solar system, the Goldilocks zone, but we are in the same type of zone as we go around our entire galaxy. We're that little pink guy there in between a spiral arm there, about halfway out. And that's the right place to be if you want to live in a galaxy, which we do. Okay? If we were any closer, okay, in the center of our galaxy, the stars are very densely compact and supernovas are very common. So that's a dangerous place to be any closer in. And there's a black hole in there. Most of you heard about that. Very center produces deadly radiation that would also make it uninhabitable. So there's only so close you can get to that guy and be able to have any life. But we're not near there, so that's good. We're in this Goldilocks zone again, around just right where we need to be for life to exist. We also don't want to be within a spiral arm, one of those arms that you saw, where many supernovas also take place. It's a dangerous area to be within a spiral arm. Much more activity happens, solar or cosmic activity happens in the spiral arms that would be harmful to our world. We don't live there. We live right there at the right spot, right where that little line points to. That's us. This is not a real picture, by the way, as you might imagine. This is artist's conception. Nobody's been out there to be able to take this picture, but that's where we are. We're exactly where we need to be, off the edge of a spiral arm where conditions are the most ideal for complex life. We are also located in the best position to allow astronomical research. We can study both the nature of our own galaxy as well as distant galaxies and stars and the entire cosmos. Albert Einstein, pretty bright guy, he said, the most incomprehensible thing about the universe is that it is comprehensible. Now that kind of seems sort of funny. Sounds like Yogi Berra, if anybody follows sports. He always had some weird saying. The fact is, it's so unlikely that we would live in a spot on a world, in a solar system, in a galaxy where we could see everything. And we could learn about everything, and we could study everything. We can look out and see these stars that aren't too far off in a spiral arm, just beautiful stars, and we can study those stars. We can learn some things about those stars that helps us understand about our own solar system. We see beautiful things like this nebula, and how glorious and vast they are, and amazing to look at and to wonder at. And one of my favorite nebula is the Veil Nebula. Beautiful things. I mean, it's like artwork. We can see it, is the thing is. If we lived on Venus, we couldn't see it. If we lived in a spiral arm, we couldn't see it. We live right where we need to live, to be able to look out into our own galaxy and see these beautiful things. And then we can look into the center of our galaxy and see and study it. I mean, here's the Milky Way, we call it. And you can look in there and you can see a lot of things about it. Sometimes you have to use, there's so much stuff in the way, you have to use different kinds of radio telescopes, but you can view so many things and learn so much about our own galaxy. And then we can look out, because right where we are, we can look out and we can see these other galaxies, amazing galaxies, billions of galaxies out there that we can look at. Some of them are so beautiful. I have a program, I don't use it much anymore, but it's called Space Engine. And it's silly, I know. But basically, it's not a video game. It's a thing where you get it and you can travel anywhere in the universe, the known universe you want to, virtually, okay? And you can come into the Andromeda Galaxy and look at and see what we know about it, and then you can fly off. You got to go pretty fast, big distances, and you can see, and I love that. I could go around looking at different galaxies forever because they're so amazing. But what's really amazing is the fact that we can see them the way we do, because we are that privileged where we are in our space in the universe. Mike.
Yeah, I'm even just blown away when I use Google Earth, and you can hit this certain icon and it will take you randomly to different places. And there's so many different places here on Earth that are even unimaginable. Mm-hmm. You know, that the same God who created the earth is the God who, of course, created the universe. And we get a little taste of his infinite wisdom and the variety of his creative power here. It's got to be, you know, a billion, trillion, quintillion times greater out in the universe.
Yes. Amen. It is. The Sombrero Galaxy. I could go all day showing you different galaxies. I think they're gorgeous. If you want a space engine program, just look it up. It's free. It's a little techie, but you basically fly around and pretend like you're a spaceman. Okay. And then we look out and see not only individual galaxies, but we see all these just countless galaxies, more than we can basically count. They're just, all these things you see are different galaxies out there. We can see them. We can study them. It's not an accident. The same passage here. The heavens declare the glory of God. The skies proclaim the work of his hands. Day after day they pour forth speech. Night after night they display knowledge. And we can learn that because we can see it. A few other planetary conditions that we won't go into detail on. Protected by gas giant planets, Saturn and Jupiter, protect us from asteroids. There's a whole study there you can look into. It's amazing. Why are those planets where they are, and why are they the size they are? They're guards. They guard us in a way that is too amazing to be by chance. We have a nearly circular orbit, which is very important for mild seasons. We have the correct mass. We talked about that a little bit. Ratio of liquid water to the continents is something that is important. We have the right range of ratio there. Moderate rate of rotation. So that helps us with the daily cycle. You know, if our rotation was 24 days it took the Earth to revolve, boy, we'd be in a whole different mess. We'd be in a mess. We're not in a mess now. Now it's just ideal. What are the odds? That's the question. That all these things could come together, every one of them necessary for life, and it all just happened by chance. Well, this one is a little more difficult to figure out than when we looked at DNA and tried to calculate its odds of a monkey typing on a typewriter and being able to produce, a certain amount of, like a psalm or a sonnet or a book, and we compared that to the being able for DNA to come together by chance. That's a little easier to kind of figure out. That's not so much. You've kind of got to get a value to each one of these. And 1 in 100, I think, is very conservative. Where we are in our solar system, 1 in 100 chance, easy. It's more remote than that. But we're going to give 1 in 100 to each one of these conditions we've looked at, and the ones we didn't have a chance to look into that deeply. And so that's one chance at about 10 to the 35th. One chance in 10 times 10 times 10, 35 times, which is one chance in a billion, 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 billion. Now, it doesn't mean a whole lot either, other than the fact that there's only a billion, billion planets in our universe. Most cosmologists and astrophysicists believe there's only about a billion, billion. That's a lot. But this is one chance in something far greater than that. Very, very unlikely that this would ever happen. These conditions were arranged. I think that's the only reasonable conclusion. These conditions were arranged. Any questions here? We're going to kick over to something very related. We're looking at the conditions that we can see that around the Earth and our solar system and so on that have to be here for us to be able to live and enjoy this Sunday morning together, sitting in these pews, ready to worship God here in a bit. And we're going to switch over. Mike, yeah.
Yeah. So the equivalent of the evolutionary theory amongst physicists, as far as the formation of the universe, is the Big Bang theory, and the idea that everything originated from something infinitely smaller than the head of a pin, and then exploded outwardly and formed everything that we now see. And and as I, when I was studying it in school and have read about it since. Really, even the mechanism for the formation of planets, they don't really know that, let alone, all of these details. Isn't that correct? I mean, they've never really observed.
Oh, yeah. No.
They've never observed gases expanding outward and starting to swirl and do all this fanciful stuff.
Because in their explanation, it takes billions of years for that process to happen.
Right.
And how long have you been around?
Yeah.
So
yeah, and again, it's when you see things like that portrayed in videos, it's like Disney animators have done it. It's not something that they have
observed or have any evidence
Right.
that it actually happens. Yeah, exactly. Glad you brought up that Big Bang there. That's how most, by far, I would say 99% of evolutionists and atheistic physicists believe this universe came into existence. It blew up from like you explained, a very, very small particle into everything that you see. Okay, brings up our next point here. Design of the cosmos can be seen in the fine-tuning of the universe. Fine-tuning. And we're going to look at a few things about this fine-tuning, understanding that most physicists have a huge problem understanding how all these few things we're looking at can be so fine-tuned to the exact amount they need to be for just matter to exist, or carbon to exist, or anything. It is on a knife's edge, standing on a knife's edge, standing on a knife's edge, standing on. That's how fine-tuned this is. So we'll look at some of that here. Fine-tuning of the universe, and we're going to use this guy to help us understand how on remote some of these parameters and these qualities of our universe are. That's you think that's a yardstick? It looks like a yardstick, but it's not. It's a measuring stick, but it's a whole lot longer than a yardstick, because we're going to be looking at the fine-tuning parameters and how much they can vary for these things to actually exist. And so we're going to look at 1/8 of an inch on this yardstick over however length it is. We got 1 out of these many chances for this to be right, for this universe to exist. So we'll apply that. I'm just showing you this yardstick. Not a yardstick. I just told you it wasn't a yardstick. Measuring stick. It's a whole lot longer than a yard, even though you can't see it going off the edge of the screen there.
It's your tuning scale, right?
That's what it is. Martin Rees, a famous Britain astronomer in Discover magazine, November 2000. The universe is unlikely, very unlikely, deeply, shockingly unlikely. It's quite fantastic. Just 6 numbers underlie the fundamental physical properties of a universe, and each is the precise value needed to permit life to flourish. Now, nobody in here is a physicist. Raise your hand if you're a physicist. Okay. I studied physics in college. I'm not a physicist. I love physics and I love the study of how things work, but I don't know what this guy knows. And he knows a lot, and he's come to the conclusion, like most scientists, that the universe we have are based upon these laws of nature that are so fine-tuned, it is this unlikely. Now, last night you probably had trouble sleeping thinking about this next one. The ratio of electron to proton mass, right? Probably not. Keeps you awake every night. Okay, here's the first one we want to look at. You probably haven't thought a lot about it. You heard of protons, you've heard of electrons. You know they're necessary for all matter to exist. Well, there's a ratio of electron to proton mass, their weight, that is so precisely tuned, if it varied at all, then if either protons or electrons were any heavier or lighter, atoms would not hold together. That's the sad state of things. If they varied 1 part in 10 to the 35th, 10 times 10 times 10, on this scale, okay, here's our little 1/8 of an inch coming up here. If it varied 1/8 of an inch on a scale that was not as far out as the moon, or as far out as Jupiter, or as far out as Pluto, or the whole solar system, but 1 billion miles. That's the little over the circumference of our galaxy that we looked at earlier. If it varied just that one part over that distance, then protons, atoms wouldn't be able to function. It's that balanced, that important. Now, the whole problem physicists have is how do you get this from a big bang that starts everything, that all this type of beautiful balance between protons and electrons happen? They are totally without an answer. Well, we'll give you the answer at the end of this, which we're not going to be able to do today, but next week. What their best explanation is for any of this, and you're going to laugh at it, and you probably heard of it before, but you'll laugh at it, and it's just not one that makes any sense at all. Anyway, so here's one point of fine-tuning that is absolutely critical as far as the way things work in nature. Okay, another one that probably kept you up. Strong nuclear force. This is the force that holds atoms together. Protons and electrons have to have a certain weight balance, but there's also a certain amount of force that keeps atoms together and keeps you together because of it. This is a small-scale attractive force that holds the nuclei of atoms together. If it were any weaker or stronger, the universe would have far fewer stable chemical elements, eliminating several that are essential to life. So you might still have some elements if it moved a bit on this scale, but if it moved more than just 1 in 10 to the 37th part, you wouldn't have carbon and you wouldn't have some of the other elements you need to have for life. So here's our scale again. What is this? What is, I mean, if it varied 1/8 of an inch along a scale that was this long, which a scale that's 1 billion miles long, which is out past the first galaxy, out past the third and fourth and fifth and sixth galaxy about. It'd be further than that. That's how long this scale would have to be. And if you varied it 1/8 of an inch, this is what this number represents. But it's that precisely tuned that atoms can exist. Explain that by chance, and nobody really can. Let's go on to a few more. The ratio of gravity. Now, you've heard of gravity, right? That's one we've heard of. To electromagnetic force. That one maybe not so familiar. Again, it's a molecular electronic force. There's a certain ratio that has to happen, and I'll read what my notes say here. If this force were larger, or this ratio was larger, stars would become too hot and burn out too quickly. If smaller, stars would never burn at all, and heavy elements would not be produced. Also, atomic bonds and complex molecules could not form. Again, you don't have to know what this stuff is. Just realize that most physicists realize that it is tremendously balanced. This one in 1 part to 10 to the 40th. So you got our stick again, and you put our little 1/8 of an inch on there. So that stick now, it has to be within this much on a stick that is 4 billion miles long. Not 4 billion, but billion miles long, which is bigger than the entire universe. Okay, this one you're gonna throw me out on. Mass of the universe. Again, if we have a big bang, this bang is going out, the mass of the universe, all the different parts and the energy have to be a certain amount for us to expand the way we are supposed to be expanding, that we can look and see now that we're expanding at a certain rate. This needs to be adjusted to 1 part in 10 to the 60th. Adding or subtracting a single dime to the mass of the observable universe would be enough of a change to make physical life impossible. A dime. Now you're thinking, wait a minute, I threw out probably 2 pounds of trash last night. Well, you threw it outside, but you didn't take it out of the universe. Well, yeah, but I had a campfire just the other day, and I burned up some logs. Didn't that destroy some of the mass of the universe? No. Some of it turned into smoke, some of it into charcoal, some of it turned into energy. The mass of the universe still balanced. By a single dime, if it changed, the universe would expand too quickly and disintegrate, or it would collapse on itself if it was too slow. And we couldn't have what we have. Okay, Mike, yeah.
You know, even though a bang or a blast is something we observe as random, there are people who are experts in explosives. And we've seen these videos where they'll go to implode a building, and if they don't have the right charges, the right force involved, the building might just tilt, or it might not completely collapse, or and become something dangerous. So if it takes that kind of control to just bring down a building, what kind of control is involved here in balancing the universe as God is doing? It's like that.
As he has. Now, God can make the universe any mass he wants. Yeah. It happens to be the mass it is.
It's like that.
But for this to work, according to evolutionists, it has to be this tight for things to exist.
Yeah, there's a performer who does this juggling act where he takes an apple, an axe, and a watermelon or something like that, and he's our chainsaw, and he's juggling each one, and he has enough control to stop and take a bite out of the apple. Well, God has done something so much infinitely greater here in juggling these various planets and solar systems and galaxies and the universe as a whole. It's just, of course, obviously beyond our comprehension, and we should just be in wonder and worship him, not write him out of the scene.
Amen. Amen to that. Well, we're just past time. Appreciate your attention. Again, we're looking at this particular part. We've got probably another 15, 20 minutes to finish this next week, and see what's going to happen exactly. But after we're finished, whether that's next week or not, Brother Bill Downey begins a study in the book of Galatians, which really is more important than what we're doing. But even as I think this is important. So come back and be a part of the conclusion of this class, and also the start of our Galatians class, if you would. Thanks for your attention and your comments.